Hello, my name is Haven, and along with Jim and Ryan, we make up the virtual Vikings or teammate. We'll be going over our designs for autonomous homesteading. Bottom line up front, homesteading is very labor intensive, and during the pandemic, many people are interested in living a more self sustainable lifestyle. We believe that our designs will help to automate some tasks that would be especially appealing to the part time or perspective or disabled homesteaders, as well as get some precious time back to the more professional homesteaders to make life a little bit easier. The three designs we'll cover will be the smart greenhouse, a large pest deterrent system, and an automated natural barrier maintainer.
So the first robot is called Freyr's Cabin, and it's an Arduino that is using soil moisture and temperature and humidity to make some set points. So we have a set point for temperature and humidity, which if it's reached will turn on the fan, and if the soil gets too dry, then the submersible pump will be activated via relay, and that's its algorithm loop down here.
All right, moving on to the deer slapper. This device will use sound, light, and touch in attempts to turn pests away from the homestead using PIR sensors to activate two different phases of deterrence. The outermost PIR will activate an air horn, while the innermost PIR will spin poles depicted here in the middle of your screen and turn on the integrated LEDs to deter the animal through light and touch. The design is customizable any lengths or heights as well as around any obstacles. The design can also be controlled from the central Arduino hub as depicted here at the bottom left. This will enable users to fully integrate multiple robots from one location, which will be explained later in the video.
My name is Ryan Neal, and this is my design for a hedge trimmer. So first, the central hub Arduino initializes a detection scan, which drives the hedge trimmer down the rail by use of a foot motor and ultrasonic sensors. If at the end of a detection scan, a certain resistance value has been met, then cut mode will be activated and both servo motors will rotate and it'll run back and forth down the rail again. And after every detection scan in cut mode, the central hub Arduino will be notified.
So for collaboration, the robots will be based on a LoRa type network, and this can also be a mesh network because if you're at a homestead, maybe your devices are far enough away from each other that you might need to use the intermittent nodes as relays to then get back to the central hub Arduino. And so our central hub Arduino, this is kind of a mock-up of what it should look like, is essentially like a tablet that's or large screen that's based on the input from those robots that then could provide real-time data, and the user could then use that screen to then send information back, maybe change set points, change other parameters, and then if this integrates with the internet, it can also offer remote access from any connected device through a smartphone app. We also have some benchmarking comparing these to other devices. And so, like our watering system, other ones I've found don't monitor soil and moisture. For the deer slapper, the other competing solutions are expensive and don't include a physical deterrent. Our hedge trimmer, that's the closest thing I could find, and it is very expensive and doesn't move on its own. And none of these have a central hub Arduino integration, so that's why we would prefer ours.
So in conclusion, compared to similar solutions and regarding the research we've done with unmet needs, we do believe our system is both low cost and scalable. And so some of the physical implementation steps we could take would be to actually construct our devices, test them in front of our stakeholders, and then of course refine our designs. Thank you so much for listening.